back, grade 12s. Yeah, now we are doing part 2 on our videos on chemical equilibrium graphs. In part 1, we dealt with concentration, the effect of concentration on the equilibrium position. Now, in part 2, we are going to deal with the effect on pressure on the position of the equilibrium. So, now the effect of pressure is very simple. We are going to deal with this question 2.1 and 2.2, and then in part 3 we will deal with the temperature. So here is a question, changes in pressure. The question says, consider the following reaction that reaches equilibrium at a certain temperature. So you have N2 gas reacting with H2 gas to form this ammonia gas, which is NH3. The reaction is balanced. 2.1 says, explain the effect on the increase in pressure on the equilibrium position using Le Chatelier's principle. And then 2.2 says, explain the effect on the decrease in pressure on the equilibrium position using Le Chatelier's principle. So we want to see when you increase the pressure on the system that is at equilibrium, what's going to happen to the equilibrium position. And when you decrease the pressure on the same system, what's going to happen to the equilibrium position. And you must use Le Chatelier's principle to explain what happens. So let us look at this question. Okay, let us look at this reaction. So we have N2 reacting with 3H2 gas forming 2NH3 gas. Now, first thing that you must check, all of your substances must be in gases. So all of them are in gas form. So what does the rule say when it comes to an increase in pressure? What does the rule say? The rule say an increase in pressure, the increase in pressure in the system at equilibrium will always favor the side with few number of moles of a gas. So an increase in pressure will always favor the side with a few number of moles. So according to our equation, which side has a fewer number of moles? You can see here you have 1 mole of N2, 3 moles of H2. So on the reactant side, it's like we have 4 moles of these gases, and on the right hand side we only have 2 moles of the ammonia. So the side with few number of moles in this equation is the right hand side, the product side, which is the forward reaction. So how will the system going to react now if you increase the pressure in this system? The system is going to oppose this by doing what? By increasing now the concentration of the gas with few number of moles. By increasing the concentration of the side with few number of moles, which is the ammonium gas in this case. Then which side of the reaction will be favored? We said it's going to be the forward reaction. So the forward reaction is favored. That's why the product side increases in concentration. Then what will be the effect on the reactants and products? The effect is that the concentration of the reactants will increase and the concentration of the products will increase. This is Le Chatelier's principle. So an increase in pressure favors the side with few number of moles. The system will try now to oppose this increase in pressure by increasing the concentration of the gas which has less number of moles, which is the forward reaction in this case. That's why it is favored, and the concentration of your reactants will be decreased and the concentration of your products will be increased. So that's what happened when pressure is being increased. Now let's look at the graph now and try to see how this looks like on the graph. Okay, let me just give you a picture here. So you have 1 mole of N2 react with 3 moles of H2 and form the 2 moles of NH3. So this is a system, and this system is a closed system and it's at equilibrium. So we can see the volume here is very big, and these gases inside are chillaxing there, hitting the walls of the container, bumping on each other. So the space is big and there is more random collision and movement of the gases. Now what you do here, you decrease the volume. If you can see here, the volume is being decreased. The only way to increase the pressure in a system, you have to decrease the volume. Because according to Boyle's law, if you remember, the volume of an enclosed gas is inversely proportional to the pressure, which means that if you increase the volume, if you decrease the volume, you are actually increasing the pressure. So here there was less pressure in this one. There was less pressure. Why? Because there was more available space. The volume was big. And then we decreased the volume now. When you decrease the volume, that means you have created now a disturbance in the system. So what's going to happen here, the pressure inside these gases will increase. And now the system is going to look now which side that has few number of moles. Remember, on the reaction side, we have 4 number of moles, and on the product side, we have 2 number of moles. So the system now will automatically favor the side with few number of moles by actually increasing now the concentration of that gas, which is ammonia, and decreasing now the concentration of the side that has more number of moles. That's how it's going to relieve itself or oppose this disturbance. Now, why increasing the concentration? Now, if you look at the formula of the concentration, C is equal to N over V. This formula says if you decrease the volume of the container, you are actually increasing the concentration of the reaction. So a decrease in volume is actually an increase in the concentration. So we can see here that the concentration and the pressure, they are like directly proportional. If the concentration was increased by a decrease in volume, pressure was also increased. So I'm going to say here that the increase in the concentration is similarly increase in the pressure, or the increase in the pressure is also an increase in the concentration. But you have to decrease the volume to increase pressure, and that decrease in volume is actually an increase in the concentration. That's why the concentration now of this side is increased and the concentration of that side was decreased. So let's look at the graph now. How does this look like? But keep in mind that when you want to increase the pressure, you have to decrease the volume. And when you decrease the volume, you are actually increasing the concentration. So the concentration increases as the volume decreases. As a result, pressure is also increased. So this is the graph now. We have N2 is represented by the red graph. We have H2 represented by the blue graph, and H3 represented by the yellow graph. We said now pressure is being increased in this situation. Pressure is being increased, and what is the rule? When you increase the pressure, you are actually favoring the side with few number of moles. In other words, the concentration of this one increases. So the concentration of this side will decrease. So we want now to see that on the graph. So the first thing that you must know is that all of these substances or gases, they are in a closed container. So everything here happened at once. It's not like the concentration whereby the concentration of this will increase and the concentration of that will decrease. No, here the system is in a closed, the reaction is in the closed system. When you decrease the volume, the pressure increases automatically. What happens to the concentration? The concentration is actually increased. When you decrease the volume, the concentration automatically increases. The concentration of all of them will automatically increase. In other words, the concentration of N2 will increase. The concentration of H2 will increase. The concentration of NH3 will also increase. Three of them at the same time, they will increase. Why? Because now the volume is being decreased and the pressure is being increased. So the system wants to respond now to this disturbance. So the system said, okay, let me look for the side that has few number of moles. Which side is that? We said it is the NH3 side, which means the forward reaction will be favored. So this is NH3. So the system now favors this side, NH3. It increases the concentration of NH3, and then in response to the reactants, it decreases now the concentration of the reactant and decrease now the concentration of the reactant until a new equilibrium is being reached. This is the new equilibrium. This is the new equilibrium, and this is the new equilibrium. So this is what happens now. When you increase the pressure, you are increasing the concentration, but you are increasing the concentration of all your substances, and then the system now looks for the side that has few number of moles, and then it favors that side. In this case, it's NH3, and then the concentration of the reactants decreases, and a new concentration, a new equilibrium is being reached. So that was the first question. The second question was saying, explain the effect of the decrease in pressure on the equilibrium position using Le Chatelier's principle. Now we want to see now what happens when we decrease the pressure. So the rule now will say, if we decrease the pressure, the decrease in pressure will always favor the side with more number of moles. Which side has more number of moles? It is the reactant side. That means the reverse reaction now will be favored. So the reverse reaction will be favored. So that's the reaction side that will be favored. How will the system react? The system now will try to oppose this decrease in pressure by increasing now the concentration of the side with more number of moles. In other words, the concentration of this side will be increased and the concentration of that side will be decreased. That's how the system will react, and that means that the effect now on the reactants and products, the concentration of your products, which is NH3, will decrease, and the concentration of your reactants, which is N2 and 3H2 and 3H2 will increase. So the rule said if pressure is being decreased, the system will favor the side with more number of moles. The side with more number of moles is the reactant side. That means the reverse reaction will be favored. So the system responded by increasing now the concentration of your reactants and decreasing the concentration of your products. So let's look at this now in a graph. Okay, before we go to the graph, let's look at this again. So this was the system initially, and the system was at equilibrium. So we said now we want to decrease the pressure of this system. So to decrease the pressure of this system, we have to increase now the volume of the system. So we can say now this is a bigger volume. Now, when you increase the volume, what happens now to the pressure? When the volume was being increased, the pressure now is being decreased. So we know the formula C is equal to N over V. So if you increase now this volume, what are you doing to the concentration? You are decreasing now the concentration. Now the concentration that will be decreased is the concentration of all your substances. But the side that will be favored now, it will be the side with more number of moles. And the side that has fewer number of moles, in this case, it will decrease. But the concentration of these ones now, the left-hand side, the concentration of these will increase. So when we decrease the pressure, we can only do so by increasing the volume. Increasing the volume is actually a decrease in the concentration. So we see first the concentration of all of these will decrease, and the system will favor the side with more number of moles. That side, it will favor this side, and the concentration of that side will decrease. So let's do that now in the graph. Okay, here is a graph. So we are saying now in this case the pressure was being decreased. When the pressure was being decreased, or the only way to decrease the pressure, you need to increase your volume. So when you increase the volume, you are actually decreasing the concentration. So we'll see a decrease now in the concentration of that one. We will see a decrease in the concentration of that one. We will also see a decrease in the concentration of that one. All of them, they will have a decrease in the concentration. But the system now will respond by favoring now the side that has more number of moles, which is the left-hand side, or the reversed reaction. So the system now will respond by increasing the concentration of your reactants. In other words, the concentration of N2 now starts to increase. The concentration of H2 also increase. But the concentration of your products will decrease until a new equilibrium is being reached. So this is how your graph looks like. When the pressure is increased, the concentration, all of it increases, and the system starts to favor the side with fewer number of moles. But when the pressure is being decreased by increasing the volume, the concentration also decreases. So you see 3 lines going down, then you know this is the pressure that was being decreased, and the concentration of all decreases, and the graph starts to favor the side with more number of moles, and the side with few number of moles will decrease. So this is how the graph of the pressure will look like. So now we are done with this one. We are going now to the third factor, which is the temperature, in the next video. So let us now go to the next video.